So I color coded this a little differently, each of these for the layers, because the next step for 4a is we're going to start finding the actual derivatives. So with the chain rule, you start on the outside. You start on the outside. Find the derivative of that. Everything on the inside stays exactly the same. Everything you didn't touch stays exactly the same. Later on, you'll find the derivative. So with 3a, I color coded it. The yellow is the first layer. Something to the third power. That's what we're going to do first. Everything on the inside is going to stay. Once we're done with that, then the next thing we're going to find is the derivative of sine. Just sine. Everything else is going to stay. And then after that, we're going to find the derivative of something to the 1/2 power. Everything on the inside is going to stay. The last thing we do is the derivative of the inside. Okay? So there's 4 layers, but if you keep them separate, it's not as bad. Okay? 4 layers is about as far as you'll have to go. Most problems, you'll have to go 1 or 2 layers. So most problems on tests or quizzes, you just go 1 or 2 layers. But occasionally they'll give you a 3 or 4 layer. Okay? Okay, so let's do 4a now. Okay, so now that I know these are my layers, the first thing I'm going to do is I'm going to find the derivative of the outside. The outside is the yellow, just the yellow. The yellow is something to the third power. If we have something to the third power, we're going to move that power to the front and subtract 1, right? That's what we're going to do. So I'm going to move, let me see, f prime. I'm going to move the power to the front. Everything on the inside stays exactly how it is. I'm not going to touch anything yet. I'll get there, but not yet. Subtract 1 power. That's the derivative of the outside. That's the first layer. Chain, multiplication. Okay. Now, let's go to this inside, the first inside. What is derivative of sine? Cosine. So cosine will be there. Everything else stays the same. Everything else stays exactly the same. Now I go to the second inside layer. Something to the 1/2 power. Well, this is kind of like the outside layer. We have something to a power. So the power rule says we move that power to the front and subtract a power. That's what we're going to do. 1/2 is going to come to the outside. The inside stays the same. I subtract a power. And then the last level, the third inside, the fourth level, the last inside. Find the derivative of the inside now. Just 4. Chain 4. When I say chain, I mean multiplication. That's the chain. The chain that's linking them all is multiplication. I have multiplication here, here, and here. Done. That's the derivative. That is the derivative. Now we have some things we can multiply. Like I have some coefficients I can multiply. I can multiply 3 times 1/2 times 4. Those are all coefficients I can multiply. So 3 times 4 is 12, times 1/2 is 6. Everything with a positive power, I'm going to leave here. I'm going to write with the 6. The last guy This guy here has a negative power. So that guy's going to go to the bottom. And that's it. Here's what I see a lot of people wanting to do. I see a lot of people, oh, they all have 4x plus 1s. So let's cross them all out. Can I do that? No. Because even though it's 4x plus 1, the top 4x plus 1s are not actually 4x plus 1s. They're angles. They're angles that belong to sine and cosine. So they're not able to do that. If this sine wasn't there, if this cosine wasn't there, then for sure you could do that, absolutely. But we can't do that because these 4x plus 1s belong to sine and cosine. Okay, the only other thing you could do is change the 1/2s back to roots. It's not necessary, but so instead of 4x plus 1 to the 1/2, they might do that. Like I said, it's not necessary because it means the same thing, but since they started with roots, they might change them back to roots. That's the only other thing. Okay? So it's about finding the layers and then going step by step. That's all it is. All right. Okay, let's try letter B now on the next page. Let's try letter B. So letter B goes with 4B goes with 3B. 3B and 4B go together. Okay. So again, I color coded it just to show the layers. The layers. So we rewrote it. The first thing, the most important thing before you start the problem is to rewrite it. If it has roots, change it to powers. If it has a fraction, and if you can do this, like I could 100% do the quotient rule to do this problem. I could, right? You could use the quotient rule. Change this to the 1/2 power and then do the quotient rule. You could do that. That works too. But since we're doing chain rule, I'm just showing you how to do it with the chain rule. So yesterday we did this. So now the outside is the yellow. So I have a 3 in front, and then I have times something to the negative 1/2 power. So the first thing I'm going to do is move that power to the front, multiply, and then subtract a power. Everything on the inside stays exactly how it is because I haven't got to it yet. Okay, so that's the first thing I'm going to do. G prime. So negative 3 over 2, because when I move the negative 1/2, should be negative 1/2. There you go. Move the negative 1/2 to the front. And then we take away a power. Okay, everything on the inside stays exactly how it was. Okay. All right, that's the first layer. Chain. The second layer. The second layer was tangent. What's the derivative of tangent? secant squared. So secant squared, everything else stays the same. Secant squared, everything else stays the same. Yeah, that 1/2 shouldn't be there. This one's actually only got 3 layers. Sorry. Because remember yesterday we had switched it over from it was a negative 1/2. So because we did that, this one's only got 3 layers. Okay. Now I got to find the derivative of the last layer, the blue. 8x. Chain 8x. Okay. Coefficients I can multiply. So I can multiply negative 3 over 2 times 8x. Those two are unoccupied with anything. They don't have signs or secants or tangents. So if I multiply 8 times negative 3 over 2, I get negative 24 over 2, which is negative 12. So I get negative 12. This guy's got a negative root, so I'm going to move that to the bottom. Secant squared does not have a negative root. Yes, sorry, yeah. Thank you. Forgot about that x. Yep. That thing I boxed in orange is going to move down to the bottom because it has a negative root or negative power. So it's tangent 4x squared plus 1 positive 3 over 2. And like I said on the last one, you can give it back its root if you want. It's not necessary, but since it started with a root, so it would be the square root cubed. Either of those are okay. Okay, either of these are okay. So when you do this, it's very important that you have a plan. Because as you're doing it, it's complicated enough keeping everything straight that you don't want to kind of have to think while you're doing this. So come up with a plan. This is what I'm going to do. I'm going to find the derivative of this, derivative of this, derivative of this. Once you do all of those things, you can, it's easier to see at the big picture. So before you do these problems, I want you to have a plan. What am I going to do? This is what I'm going to do. Okay. So my plan for this one was rewrite it. That was my first plan. Rewrite it with powers. Okay. Rewrite it with powers. After that, what's the outside? What's the first layer? What's the second layer? How many layers does it have? What's the derivative of the first layer? What's the derivative of the second layer? What's the derivative of the third layer? And go on from there. Okay. Okay. These are the hardest problems you'll have. You won't have very many of these. These two, A and B, they're probably the hardest, some of the hardest chain rule problems you'll have. Most won't be this bad. Like I said, most problems you do with chain rule will have 2 or 3 layers. That's it. They'll have the outside and then an inside, or then maybe another inside. But this one had 4 layers, so it made it a little bit difficult. Okay, so let's go to 5 now. Number 5. Okay, so this guy is multiplying. We have multiplication. We're multiplying 2 things. I'm multiplying x squared plus 1 times the root, 2x minus 3. So if we want to find multiplication, if we want to find the derivative of 2 things being multiplied, what do we use? What do we always use? Product rule. That's what we're going to do. That's what we're going to do. We're going to do the product rule. Before I start, though, I see that I have a root. So I'm going to change that. So I'm going to rewrite it. X squared plus 1. And then this guy, I'm going to say 2x minus 3 to the 1/2 power. So still this guy times this guy. It's still multiplication. Okay? Product rule. Product rule says, rewrite the first one. The first one is the pink one, the pink purple one. So x squared plus 1. I'm going to rewrite it. Since it's a binomial, I'll put parentheses around it. Times the derivative of the second one. The derivative of the second one has layers to it, right? It's got a layer to it. Let me rewrite it. It's a chain rule problem. What is the first layer? Well, the first layer is something to the 1/2 power. That's the first layer. And then the second layer is, what is that something? That's a chain rule problem. I have 2 layers. So to find the derivative of that guy, I have to use the chain rule. Okay? So the yellow, the derivative of the yellow, something to the 1/2 power. Okay, move the 1/2 to the front. Everything on the inside stays exactly the same. Subtract a power, a full power. Chain. Now I find the derivative of the blue, the inside. The derivative of the blue is just 2. Done. It only had 2 layers, the outside and the inside. Okay, plus. Now I got to do the opposite. The first one rewritten, so I'm going to rewrite the second one rewritten, times the derivative of the first. The derivative of the first is just 2x. That's the derivative. Now, if I were doing this problem on a test and it was multiple choice, that answer would not be there because it needs to be a little bit cleaned up. So what I'm going to do is I have 2 terms. I have this guy and this guy. They're being joined by a plus in the middle. So on the first one, the left term, I can multiply some things. I can multiply positive 2 and positive 1/2 because they're both coefficients. 2 times 1/2 is just 1. So I have x squared plus 1. I'm going to move 2x plus 3 to the bottom because that one had a negative power. The second term. The second term doesn't have any negative powers. I can't multiply 2x times anything. I can't even distribute. I can't even distribute here because the only time I can distribute is when the power is 1. If the power is anything other than 1, I can't distribute. So I can't do anything. So I'm just going to put the 2x in front. What's up?
The 2x, we changed it to +3. But in the original, it's -3.
Oh, yeah, I did. Sorry. Thank you. Yep. For sure. And also I see it while you mentioned that mistake, I see another mistake that I made. The derivative of the inside. Oh, wait, no. No, sorry. No. I looked somewhere. I looked wrong. Yep. So I need to change all those +3s to -3. Yeah. For sure. The 1/2s, you can put the root back. I mean, you could if you wanted to. It's not necessary. So instead of 1/2, you could just have like a root here and a root here instead of the 1/2. That's okay too. Not necessary, but it's okay. So now we're mixing, combining rules. That problem, we use the product rule. Inside of the product rule, we use the power rule and the chain rule. Okay, so mixing powers is definitely something they're going to ask you to do. Wasn't that hard? There wasn't many layers, but they will ask you to mix rules. Okay. All right, here we go. Now let's go to B, which is on the next page. My first question, how many layers does this guy have? Because trust me, as much as doing this math looks hard, it's not nearly as hard as when you start looking at a problem. The first step I find is always the hardest because you're like, is this a chain rule problem? Is this a power rule? Is this a quotient rule? What? So that's the hardest step. Once you get that first step, then you can kind of get the ball rolling. So we look at this one. This is a chain rule problem. What would be the outside layer? So the outside, yeah. The parentheses to the 9th power and everything on the inside. That's the first thing we're going to do. We got to deal with something to the 9th power. And then we have to find the derivative of the inside. Now, when we find the derivative of the inside, what are we going to use for that? The quotient rule. The quotient rule. So we're going to start with the chain rule, and then we're going to move to the quotient rule. That's the hardest part. Saying it. Coming up with a plan. Because a lot of times you look at these problems and you don't know where to start. That's the hardest thing. It's not necessarily doing the problem, it's getting started, that first step. Okay, so let's find the derivative. G prime of t. We have something. The first thing is the yellow, right? The yellow. The derivative of, we have to find the derivative of something. Doesn't matter what's in the parentheses. I really don't care what's in the parentheses yet. But something to the 9th power. So we have to move the 9 in front, rewrite everything that's in the power, or in the parentheses, subtract the power. Chain. That's the derivative of the yellow. Now we have to find the derivative of the blue. To find the derivative of the blue, we're going to use the quotient rule. Okay, so now we're going to use the quotient rule. Okay. Quotient rule says low, so I'm going to rewrite the low. 2t plus 1, it's a binomial, so I'm going to put parentheses around it, times the derivative of the high, which is just 1, right? Minus. So low, d high, high, d low. The derivative of the bottom is just positive 2. Over low squared. Done. But again, that's not going to be an A, B, C. When you finish that problem, you're not going to have that answer as one of the A, B, C, D options. You're just not, because there's things we can do, especially with the second part of the chain. Over here, I can distribute. Over here, I can distribute. So I get 2t plus 1 minus 2t minus 4. And then 2t plus 1 squared on the bottom. So all I did was distribute the positive 1 and then the positive 2. I still have a negative in front of those brackets, though. So I got to distribute the negative now. So I have 2t plus 1 minus 2t plus 4 on top. And then I have 2t plus 1 squared on the bottom. The 2t's cancel out because they're negatives, or because they're opposites of each other. So this is what I have. 9 parentheses t minus 2, 2t plus 1 to the 8th power, positive 5, 2t plus 1 squared. Not done yet, because I have two fractions that can be multiplied together. So this is what I'm going to do first. So watch what I do. This guy here, I'm going to change. They're both to the 8th power, so I'm going to give each of them an 8th power. Because the whole fraction was to the 8th power. So I'm going to give each of them their own 8th power. Why did I do that? Because look at the bottom. If I put all, don't those have the same base? So what can I do with their exponents? Add them together. So how many 2t plus 1s do I have? 10. And then the last thing I'm going to do is multiply 9 times 5 to make 45 to go along with t minus 2 to the 8th power. Now you're done. So again, we stopped doing calculus way up here. Like, that was the calculus part. That's the derivative right there. We're done. But to get to an answer that, because when you see these types of problems, they're going to be on multiple choice. Very rarely are these free response questions. Multiple choice. The hardest part about multiple choice is not doing the problem, it's matching the answer. Because sometimes you'll do the problem right, and it won't, like, you'll get this answer up here, the first answer we got, and you're like, I can't find that answer. Or you'll have this guy, and that's not one of the answers. So you have to be able to say, oh, okay, this equals that, right? That's not calculus, that's just algebra. But like I said, that's sometimes the hardest thing, because the calculus part, we finished a long time ago, okay? Okay, so before we go to the last part's not very bad. I want to do a couple of practice problems to give on your own. So those types of questions, those types of problems where I'm mixing chain rule with quotient rule or chain rule with product rule. So somewhere where you have, if you don't have any room, just on a scratch paper. Let me see. We'll call this 5C. Okay, so here we go. I want you to find y prime. Find y prime. All right, so for this guy, well, first of all, there's two different ways to do this. You can use the quotient rule, because it is a fraction, it is a division. Or you can use just straight chain rule. So there's two ways to do it. There's not one way to do it. The way they got their answer, so here's the thing about the chain rule. The chain rule has multiple chains to it. So sometimes you'll have to combine the chains, whereas the quotient rule only has one fraction. So I bet you had, so which way is better than the other? Doesn't matter. They both get you the same answer. What? I'll do the way you guys probably did. So you guys probably did like that, right? That works. So just straight chain rule, no quotient rule. That works. Okay, so I'll show you. So we have two layers. Have something to the 1/2 power. And then once I do that layer, I got, so the first layer is going to be, I'm going to move the -1 and -1/2 to the front. When I do that, I'll get -1, right? 2x plus 3, subtract the power. Chain. Now I got the inside. Right? The derivative of the inside is just 2. Oops. So combine these two guys through multiplication. Move the other guy to the bottom. That works. Okay. Again, you could have used the quotient rule too. You could have said positive 1/2 and use the quotient rule there. That would have worked too. You would have got the same answer. Okay? Either one works. Either one works. Mm-hmm. Can you say it again? The x plus the 2x. Can you square? Oh, can you change it to a root, you mean? Yeah. Yeah, that's what 3/2 means. You could write it like that. So instead of 3/2, have it the square root of 2x plus 3 cubed. Yeah, absolutely, for sure. Okay. All right, so let me give you one more. Let's do one more like this, and then we'll be done for today, and we'll finish the rest. The last part is a lot easier than what we've been doing. Okay, so 5D. Let me find a good one. Here we go. So f of x, oops, 3x minus 1, 2x plus 1 root. Find f prime. So first thing I did was rewrite it, gave it a power. So the yellow is the outside. So something to the 1/2 power. Okay, so move 1/2 to the front. That guy is 3x minus 1. The inside stays exactly how it is. I haven't got to that yet. Subtract a whole power. Chain. Now I have to find the derivative of the inside. The derivative of the inside, I'm going to have to use the quotient rule. Okay, so low d high minus high d low over low squared. That's the derivative. Okay, so now what I'm going to do is I'm going to distribute. One half 3x minus 1, 2x plus 1. Six x plus 3 minus 6x minus 2. Distribute the negative. So when I distribute the negatives, the 6x's are going to cancel out. And then it's going to become a positive 2. So that would be positive 5. Okay, so I got 1/2 5 over 2x plus 1 squared. Okay. I'm going to combine some things. Okay, so first thing I can do is I can multiply the positive 5 and the 1/2 to make 5 over 2. What is negative? So if I have a negative power to a fraction, what does that mean? I know if I have a negative power to a number, that means move it down or move it up. But what if I have a negative power to a fraction? It just flips. It's reciprocal. So it flips and becomes positive 1/2. Okay, so I'm going to rewrite it like that. So I have 5 over 2. 2x plus 1, 3x minus 1, positive 1/2, 2x plus 1 squared. And this is just a 1. Okay, so watch what I do. Okay, it's going to get a little bit, not a little crazy, but it's going to I'm going to move everything under the same, no more 3 fractions. I have 3 fractions, no more of that. So I have 5, on top I have 5, 2x plus 1 to the 1/2. On bottom I have 2, 3x minus 1, and 2x plus 1 squared. These guys have the same base. What do I do with their exponents? Subtract them. Subtract them. So on top, all I have left is 5. On bottom, if I subtract 1/2 minus 2, I get 3 halves, 1 and 1/2, and that's going to be left over at the bottom. Okay.